Hi friends, today we are going to learn how to generate a CPU core voltage. A CPU core voltage is required to the CPU to function, and this voltage is approximately from 0.8 to 1.1 volt. And actually CPU core voltage is not considered as a voltage, it requires some current, and that current is something about 20 ampere to 30 ampere current. Okay, so when you turn on the laptop and the laptop is not giving the display, then you have to check all the voltages across the each coil. Like you see in this, there are different coil, like this here is a coil, here is a coil, here is a coil, here is a coil. These are the different coil, and each coil give a different voltages. Like here you will get a 3.3, here you will get a 5 volt, then here you will get a 1.05 volt, here you will get a 1.5 volt, 1.8 volt, like that. And this coil is for the battery charging. Now here there are 3 coils. This coil is for the CPU core voltages, and this coil for the graphics core voltage to function the CPU, and this chip is called the VRM chip. Now we'll see how this VRM chip function, how the VRM sections working. Okay, so in this diagram we'll see different chips require different voltages. Like we give the input 18 volt, and different pulse width modulator generate different voltage. Here generate 5 volt, then 3.3, 1.5, 1.35, 1.05, then graphics core and CPU core, and the voltage will go like this. The RAM require, if it is DDR3L RAM, the RAM require 1.35 volt, that is a VDD, then 3.3 for the SPD, and 0.75 for the VTT, or 0.67 for the VTT. That's, and the PCH require 1.05, 1.8, then 3.3, and the bias require a 3 volt, SI require a 3 volt, and the CPU require a 1.35, 1.05, graphics core, CPU core, as well as 1.5 also. Okay, so all this voltage is required to work the CPU. Now we'll see how the CPU core voltage is generated. This is a core section VRM. It's called the VRM section, voltage regulator module. Okay, for this first generation, second generation, or the third generation processor. Now this is my CPU. Okay, and this entire section is called the VRM section. The VRM section is responsible to generate a CPU core voltage to the CPU, right? So first CPU should get all these 3 voltages. Like you should get a 1.05, 1.5 and 1.8. you can check on this different coil. You should get all these 3 voltages, and then this section's ready to function. Now this is called the VRM chip or core voltage chips, and this chips require 5 volt VCC. VCC means the supply voltage to function the chip, and some core voltage or some VRM chips require a VIN voltage also. VIN voltage means the 18 volt. So some chips require 2 different voltages, 18 as well as 5, and some chips require only a 5 voltages, right? The next is these are the MOSFET. These are the different MOSFET. They are cascaded. UG means upper gate, LG means lower gate, connected to the coil and the capacitor. And the next is this is called the VCC sense or the CPU sense signal, V-sense signal. The VCC sense or the CPU sense is a signal which detect the CPU, and if this signal is not present, the VRM section won't work. It won't generate the CPU core voltage, right? So this is very important. When we connect CPU on the socket, at that time if we take a multimeter and connect multimeter, we'll keep the multimeter on the buzzer mode, and if you can connect one pin to this pin, this is called the V-sense pin, it will give the 0 ohm resistance, and if it's giving the 0 ohm resistance, that means he detect the CPU, and if it is open, it won't generate the CPU core voltage, like that. So the next is called the NTC. The NTC is a small thermistor. It's called the negative temperature coefficient. Is a small thermistor who sends the temperature below the CPU. But if the CPU is very hot, then he generate a signal and he send that signal to the VRM chip, and VRM chip terminate core voltages. It's like that. And suppose sometime if CPU is hot or this NTC is open, then this circuit won't work. Okay, so like that. So there are two criteria. One, CPU should be present, number one, then NTC should be proper, that is all, 0 volt. Okay, the next is my VRM section is ready to work. So he's required one command that is called the VR on signal. The VR on signal is a 3 volt command. Either it comes from the SIO or it comes from the different circuit, like in Quanta and Compil motherboard. This VR on signal is generated by the SIO. VR on means turn on the VRM section, and here will get a 3 volt. Here will get a 3 volt. That is called the VR on signal. So like that. See, is like that. Here it is generate. Suppose this VRM chip is a 40 pin chip. In that 40 pin chip, there is a one pin is called the VR on, or it's called the EN, that is the enable. Here you should get a 3 volt to turn on this VRM section, and if it is not a 3 volt here, then this VRM section won't work. So this is a requirement. VR on signal should be 3 volt, then VCC should be 5 volt, and if it is a VIN, then it should be 18 volt. VSense signal should be present, and the NTC should be proper. So it's like that. So once all this criteria is perfect, all the MOSFETs are perfect, and is the CPU is present, and the SIO give this VRM signal to the VRM chip, then this VRM chip generate this signal, this pulses, and fire this pulses like that. It started triggering to this MOSFET. This is called the upper MOSFET connected to the 18 volt. This is a lower MOSFET, upper MOSFET, lower MOSFET. This entire section is called the CPU core section, and this section is called the graphics core section. There are two different sections in this area. One is called the CPU core, and another is called the graphics core. Okay, the CPU core and the graphics core. So this all these three sections controlled by this VRM chip. So he started triggering this MOSFET. Okay, and once he started triggering this MOSFET, this 18 volts started a chopping here, and DC voltage gathered across this capacitor. This voltage is approximately somewhere around 1 volt or 0.8 or 0.9 somewhere. And so see in this diagram, see this voltage is generated, and this graphics core voltage given to the CPU, and that is somewhere around 0.9 volt, and the CPU core voltage, that is also something around 0.7, 0.8 or 0.9 volt, and both here something 0.8 or 0.9, here also 0.8 and 0.9, and this both voltage will gather together. See again in this animation, see both are voltage gather together, they join each other and generate a huge current. When we connect the two voltages to the parallel, at that time the current is multiplied. Okay, the current will multiply, and this current is given to the CPU, and CPU is ready to function. Once the CPU receive this current, it's called the CPU core voltage. After that, he have his own power management department inside the CPU. He received this voltage and he checked that voltage, and if anything is error, if less or more or whatever it is, he informed to this VRM chip via a SVID signal. SVID means serial voltage identification signal. This signal generated by the CPU and informed to this VRM section is like that. See, it's like this. This is called the SVID signal, serial voltage identification signal. This is a two-wire communication protocol between the CPU and the VRM chips. It's a serial bus with the CPU and this VRM chips. And once this core voltage and graphics core voltage is stabilized, after that this VRM chip generate a power power good signal. This signal is a large signal, power good. This power good signal means this entire section is working fine. Here will come out a 3 volt signal, that is called the VRM power good, or sometimes it's called IMVP power good. Okay, it's IMVP power good or the VRM power good, or sometimes it's called the V gate also. So if this VRM power grid comes out from this VRM section, that means this entire section is working fine. Okay, so now next thing, how we'll find the fault in this section if the core voltage is not generated. So what you have to do, you have to check first voltage coming or not, 1 volt approximately on the both the coil and is the graphics coil. If it is not coming, then you go to this chips and check first 5 voltage, that is VCC voltage coming or not. If this VCC voltage is coming, then you have to check this VR on signal, that is a 3 volt signal is coming or not. If this 3 volt is not coming, then check why this 3 volt is not coming. If this 5 volt is not coming here, then check why this 5 voltage is not coming. If the both signals are present, then you have to check this VSense signal. VSense signal, how you will check the VSense signal? Connect multimeter on the buzzer, connect one point to the ground, another point to this VSense. You will get a buzzer. If the buzzer is there, means he detect that CPU, he detect the CPU. And the next is this NTC signal, it should be a 0. If all these criteria are perfect, then still the CPU core voltage is not generating, then check whether CPU is not short, check is resistant. It should not show a 0 ohm. It shouldn't show a 0 ohm either here or here. If it is showing a 0 ohm, then the CPU is short, then replace the CPU. And now if it's not showing a CPU 0, that means it's showing something 4 ohm or 5 ohms, that means okay, CPU is okay. Then check all this MOSFET, whether they are any short or what. Check this capacitor. If everything is perfect, there is no shorts in the processor, all the MOSFETs are perfect, all the capacitors are perfect, then they replace this VRM chip like that. So you have to replace this VRM chip. Okay, so in this way you have to rectify this problem in core section. Thank you very much.